Good day everyone, my name is Graphics. Today we'll be looking at an aspect of technical drawing where we'll be constructing a parabola. Now, a parabola is said to be the locus of a point, right? Which moves so that its distance from a fixed point, the focus, and the fixed straight line, which is the directrix, are always equal. So what this trying to tell us is that there are different ways at which you can construct a parabola. One of the ways are rectangular method. Another way is triangular method. Another way is locus method. But at this stage here now, we'll be looking at the locus method in constructing a parabola. Now, when you are told to construct a parabola using a locus method, the first thing that should come to your mind is the word you should draw a vertical and an horizontal axis like this. Right? Then the next thing you do is to draw the vertical aspect. Just place your t-square, your z-square, your t-square, and you draw it to meet at this point. That's the second thing you do. Now, this vertical line you see here is called the directrix. This line you're seeing is called what? The directrix. There is no distance, so in most times you might give the distance that the directrix is 100 millimeter long. So that means this center line here will be at the center of the what? 100 millimeter. But in this case, it is not given. Now we are not told that the vertex is 20 millimeter from the directrix. So if I'm to measure, I'm going to measure 20 millimeter from here. This is the directrix, placing my at this point here, and I'm going to measure 20 millimeter, which is at 2. Right? So my vertex is 20 millimeter from what? The directrix. Now, the next thing you need to understand is the next thing you need to draw is for you to draw the focus. Now, since it is a parabola, the eccentricity of a parabola is what? Is 1. It meaning that the distance from the vertex to the directrix is equal to what? The distance from the vertex to the focus. So if the distance of the vertex to the directrix is 20, definitely the distance from the vertex to the focus will be what? 20. So I'm going to measure my 20. So this is another 20 here. Right? And that'll be what? My focus. Now the next thing we'll do here is to bisect the vertex and what? And the focus. So with the help of your t-square or of your compass, you bisect, or you simply just divide. Since from here to here is 20, that means in between them we what? 10. So this is, I'll call this point 1, and here we what? 0.2. Right? And I'll continue spreading it out that way. So from here I'm going to have, this is still the same 20 here. So I'm going to have the next one will be 0.3. The next one will be 0.4. The next one will be 0.5. And the next one will be what? 0.6. Right? So as much as you can. So at this point, this is 3. This is 4. This is 5. And this is what? 6. Now, the next thing I'll do is to carry my set square and draw a vertical line passing through each of those points like this. To the next point also like this. To the next point also like this. To the next point also like this. So I'll repeat the same process for all the points with the help of what? My t-square and my z-square. Use them simultaneously. Right? So this is what I'm having. Now the next thing I'm going to do is to use my compass. From point 1, I'm going to take it to the vertex, to the directrix. Can you see the directrix here? For point 1, I place it here. Right? Then I'll take, with that radius, I'll take it to the focus, which is at this point, which is at point 2 here. I'm going to mark on point 1, up and down. I'll repeat the same thing for point 2 too. Place that point 2, take it to the what? The directrix. Now I'll place at the focus, which is still at point 2. I'm going to mark up and down on 2. I'll take it to point 3, to the directrix, right? I'll place it at the focus, which is at 2. I'll go to line 3, I'll mark up and down. I'll take it to 4, from 4 to the directrix. I'm going to mark on the focus, which is at point 2. I'll go on line 4, I'll mark up and down. I'll take it to point 5 also. Repeat the same process from 5 to the focus. I'll place at the focus here. From 5 to the directrix, I mean. Right? I'll place at the focus. I'll mark on line 5, up and down. Do the same thing for 6. Also, take it to the directrix here. Mark it on the focus. And mark on line 6, up and down. Right? So better still, I can just stop at 5 if I want to. So I'll stop at 5. So I will take my French curve with my pencil, and I'm going to start marking. So take your French curve and you tend to join all these points together. So look how I want to do this. I will start from the vertex and take 3 points, right? So this is the vertex here, right? And I'm going to take 3 points, ensure that they are all together. So from the vertex, I'm taking 3 points, stopping here. You can see that, and I'm going to complete it from here. Ensure that they are all meeting. Another 3 points again. Right, from here another 3 points. Then I'll complete this. So I'm going to be having this. That is one, and I'm going to turn it this way also. From the vertex also, get another 3 points also. So this is what I'll do. So you gauge it until you get what you're looking for. Right? So complete it all. You ensure all the points are all meeting. So this is what we are having, our parabola. And sometimes you may be told to draw the tangent to the parabola. So what you do in drawing the tangent to a parabola is that what? At any point on this locus, right, you choose a point that you want your tangent to fall on, and your normal. Let me assume I want my tangent to fall on this point here, right? So what I will do is I'm going to draw a line from that, a faint line from that point to my focus, which is the focus here, right? I'm going to draw a faint line to that point, right? So what I'll do is I'll ensure that I'll now draw a perpendicular from this point on this focus to touch directrix, but that line must be what, 90 degree. So I'll draw a 90 degree line from this focus to touch the directrix. So you can use a protractor, or you can use your set square. So if I'm using my set square, that means I have to make this line here, this edge of my set square, right? This is what we call a set square here. So this side here to this side here is called 45 degree. So I'll just place the edge of it to this point here to ensure that it rhymes. Can you see that? So it is rhyming with the edge. Then from this point, I will just draw my line. Right? So this is my tangent here. This is my perpendicular line here, sorry. So let me complete it, let me close it up. That's my perpendicular line here I have. So in between here and here, it's said to be what? 90 degree perpendicular. So let me call this point C. Right? So from this point C to this point, let me call it F prime. I will draw a line to meet this point here. So from C to F, I'm going to draw my tangent. From C here, let me show you. From C to F here, I'm going to get my tangent. Right? So this is what I mean here. My faint line. So I need this tangent here, as you can see. So if I want to get my normal is a line that is perpendicular to the tangent. I'm going to draw this. So I place my compass at any given radius, or I can still use my pair of set square. I'll place it at this point. Right? I'll place it at this point. Let it be on the same line with, I'm looking at this point, so I want to draw my normal to this point. So I will ensure that my set square is aligning, the base of my set square is aligning to the tangent, right? So I'm going to be having this. Or better still, if you can't do that, so just draw your line this way. You'll be having this. So this will be, let me complete it to this point. This will be my tangent here, my normal. So this is how to draw a tangent and a normal to a parabola. Thanks for watching. We'll meet in our next video. Don't forget to click on the subscribe button.